Yeah, good evening, children. Good evening, online students.
Good evening, ma'am.
Good evening. Good evening. So, children, my screen is at the moment blank. I've shared my screen. Is it visible, online children?
Yes, ma'am. Yes.
Okay, very good. Okay. All right. So today we're going to understand how and where identities, algebraic identities, are used. All right. Let me just write one algebraic identity to explain. Now we know that a cubed, or let me. Okay. So we know that a plus b plus c the whole squared is equal to a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca, right?
Yes, ma'am.
Yeah. All right. So if the question looks like this part, now the identity has two parts, LHS and RHS. Okay. If the question looks like the LHS of the identity. See, the question will be like expand, say 3x minus 4y, say plus root 5, the whole square. Okay, so you can see that this question where we have to expand 3x minus 4y plus root 5 the whole square has three terms. 1, 2, 3 terms. Okay, and we have to find what is the value of this expression, that is 3x minus 4y plus root 5 the whole square. Now this one looks like a plus b plus c the whole square. Why? Because here in the bracket we have three terms. In the question, in the bracket, we have three terms, 1, 2, 3 terms. And here also, the left-hand side of the identity has three terms. And you can see it is squared here. So this is basically finding the square of a trinomial. This one is a trinomial, three terms, the trinomial. So this one is square of a trinomial. So here also we'll have to square this trinomial. So the question looks like this question. I'm talking about this one. This question looks like the LHS of this identity. All right. So now the answer will be the RHS. The answer will look like the RHS of this identity. The answer will look like the RHS of this identity. So we're going to answer this question, we'll make use of this identity, wherein the answer will look like the RHS of the identity. Now, if the question looks like the RHS of this identity, so you will have six terms. Okay, 1, 2, 3, 4, 5, 6 terms you will have. If the question looks like the RHS of this identity, so here in the RHS, we have 1, 2, 3, 4, 5, 6 terms. If the question looks like the RHS, now how do we make sure that the given question looks exactly like this RHS? So what do we have in this RHS? Apart from having 6 terms, what else do you observe? We see that 3 of these terms are perfect squares. See here, A squared, B squared, C squared. So the RHS of this identity has 6 terms, of which 3 terms are perfect squares. 3 terms are perfect squares. So in the given question, if you have 6 terms, of which 3 terms are perfect squares, it need not be the first 3 terms. The terms may be jumbled. You might have 3 perfect square at, at different positions. They need not be the first 3 terms only. Somewhere in the expression, you should have 3 perfect squares. So you can rearrange them. You can bring those perfect squares to the first, second, and third position in the expression. So if the question has 6 terms, of which 3 are perfect squares, the heading will be factorize. It will not be expand. The heading will be factorize. Factorize, and you will have this expression having 6 terms, of which 3 will be perfect squares. Then it means the question looks like the RHS of this identity. So the answer will look like the LHS of the same identity. So an identity, an algebraic identity is used to, used to answer questions with the heading expand or factorize. An algebraic identity is used to answer questions with the heading expand or factorize. Expand and factorize are opposite questions. Expand means you'll have to open up and bring out all the terms. Factorizes, all the terms are available. You'll have to compress them. You'll have to compress them. Expand is, it's compressed. You should open it up. Factorize it. Factorize means the terms are all, like spread. You have all the terms. You should compress them. So expanding and factorizing are opposite, opposite in nature. The question, the way you answer it, they're opposite in nature. So I'll tell you again. So we used this identity a plus b plus c the whole square is equal to a squared plus b squared plus c squared plus 2 of 2ab plus 2bc plus 2ca. Okay. So if the question is like the LHS, then the heading will be expand. Okay. So if the question is like the LHS, the RHS, the answer will look like the RHS. If the question is like the RHS, the heading will be factorize. If the question is like the RHS, the answer will look like the LHS. So an identity has both question and answer in it. An identity has both question and answer in it. If LHS is the question, RHS is the answer. If RHS is the question, LHS is the answer. LHS or RHS is not directly the answer. You should take help of the identity to answer the question. All right? Okay. Okay. So this is the question. All right. Yeah. So now the heading is factorize. And the given expression has 1, 2, 3, 4 terms. Of the 4 terms, 3 terms are, you can see the power 3. So we assume that, okay, they are perfect cubes. You can also work them in your mind and see that they are perfect cubes. Now this can be written as 3c the whole cube. 27 is 3 into 3 into 3. All right, so 3c into 3c into 3c is 27c cubed. 2b into 2b into 2b is 8b cubed. And root 2a into root 2a into root 2a. What is root 2 into root 2? 2. 2 into root 2, 2 root 2. A into A squared. Into A cubed. So we see that all these three terms are perfect cubes. So the given expression has 4 terms, of which 3 terms are perfect cubes. Now there is only one identity that can help us factorize this expression. There's only one identity. Of all the identities we know, there's only one identity in which, when I say one identity, it can be the LHS or the RHS. So there's only one identity whose LHS or RHS has 4 terms, of which 3 terms are perfect cubes. Yeah, so he wants to say, Rahul, tell me the identity. X cubed plus Y cubed plus Z cubed. No, minus 3xyz is equal to. So we should not change the signs based on the signs in the question. The signs and the identity are fixed. We should not manipulate them because we have different signs in the expression here. So the identity is x cube plus y cube plus z cube minus 3xyz is equal to. Now you see in this identity, the left hand side, it has 4 terms. The signs need not match. The signs need not match now. Okay. So don't worry about the signs. Are there 4 terms here? Yes, there are 4 terms. Of these 4 terms, you can see x cubed, y cubed, z cubed. These are 3 perfect cubes. So the given question and the left hand side of this identity, they look alike. They can be compared. Okay, so we have chosen the correct identity. Okay, is equal to, yeah, x plus y plus z Very good. Very good. Correct. So Rahul has given us the identity correctly. Okay, so this is the identity. And whenever the heading is factorize, we need to write the given expression as a product of its factors. Whenever the heading is factorize the expression. That means you must write the answer as a product of the factors of the expression. For example, factorize 35. So you need to write 35 as a product of its prime factors, 5 into 7. 5 into 7. Factorize means the answer will be a product of the factors of the given expression. So answer will always be like something into something into something. The answer will always be like this when the heading is factorize. You will not get the answer like this one, minus 3xyz. No, you will not. The connector between two things, the connector will not be a minus sign. If it is, then we are wrong somewhere. The answer for this heading factors will always be factor into factor into factor, depending on how many other factors the given expression has, into factor and so on. All right. Now, I'm going to use empty brackets. Now, see here. I'm using empty brackets. I'm going to write the signs using the left-hand side of the identity, not the question. So what do you have in the identity? X cubed. So see here, I don't know what is X. So, but cubed is fixed, right? So put that. Plus the identity, in the identity, it is a plus. So put a plus sign. Y, I don't know. I have to identify, I have to find what Y is. Cubed. Plus, take the sign from the identity and not from the question given to you. Plus, Z, we don't know. We have to identify cubed. Minus 3 into, we are going to write 3 into X into Y into Z. We are going to write now. Okay. Because what is this step for? We need to show that the given expression looks like the left-hand side of this identity. We are convinced it is correct, but you should present it. What you have understood, you should present. You must show that the given expression looks like the LHS of this identity. So you are using the RHS to work the answer. So we understood that 2 root 2a cubed is equal to root 2a into root 2a into root 2a. Because root 2 into root 2 is 2, 2 into root 2 is 2 root 2. And a into a squared into a cubed. So this can be 2 root 2a cubed can be written as root 2a. A outside, not root 2a under the square root. This is wrong. A into a is a cubed. Put the a outside the square root symbol. Not like this. Root 2 into root 2 cubed. Okay, 1 minute. I think I should. Nobody has a doubt there, but I have to clarify that because it's not, it's root 2a, not root of 2a. It's not root of 2a. No, it's root 2a. Why? Because root 2 into root 2 into root 2 is 2 root 2. And a into a is a cube. So what is this one? Root 2, the whole cube. What is this one? A, the whole cube. So together, root 2, a, the whole cube. A outside the square root. Okay. Then, what about the b term? 2b. 2 into 2 into 2, b into b into b. So 2b. 2b, the whole cubed. 2b into 2b into 2b is 8b cubed. Then 3c. 3c. 3c into 3c into 3c is 27c cubed. But now at this point, we see that the sign does not match. We have plus, what we have written is plus 27c cubed. But here we have minus 27c cubed. So you need to take a minus inside the bracket. You should not change this bracket, sorry, this sign is from the identity that we have no right to change. Here, your z term, you can put a plus or minus sign. For you are writing the x term, the y term, the z term, you are identifying that you can put a plus or a minus. But we cannot change the signs of the identity because then the result also will change. Inside the bracket, you know what you write, there you can write, you can use a plus sign or a minus sign. Outside the bracket, the signs which you take from the identity, that we cannot change. So here we see that it's minus 27c cubed. But we have a plus sign here, no? Yes or no, Saismati? Yeah, so here, if supposing you just write this, it is what? Plus 27c cubed. No, it's minus 27c cubed. So you'll have to take a minus inside here. Now minus into minus is minus. Minus when you multiply 3 times will give you minus 27c cubed. Then what should you write here? X into y into z. So we've got all these 3 terms, right? The value of x, y, and z we've identified. All right. Now minus 3 into x, root 2a, into y, 2b, into z, minus 3c. Now multiply and check. Multiply 3x, y, z and check. Multiply this one. 3 into 2, 6. 6 3s are 18. 18 root 2 a, b, c. And there's a minus here. And there's a minus outside. So minus into minus plus. Okay, so minus into minus plus. And the product is 18 root 2 a, b, c. Yeah, that's what we have there. Plus 18 root 2 a, b, c. So we are right in identifying the expressions for x, y, and z. Now we're it. So now what is this step? So we have presented the given expression. Okay. In the form x cubed plus y cubed plus z cubed minus 3xyz. So this is not the answer. We have just presented the question in the form x cubed plus y cubed plus z cubed minus 3xyz. Now we have to answer. To answer, we are going to use the other side of the identity. Okay. You have to actually continue here like this. But since there's no place, I'll just start working down here. You have to continue like this. There's no place, so I'll just work it from here. So is equal to now answer. So what's the answer? X plus y plus z. So what is x? Yeah. So you can just mention that if you want. You can just put an equal to sign here. You can just put an equal to sign here. And then here you can write x is root 2a, y is 2b, and z is minus 3c. And then you can just put an equal to and continue like this also. So is equal to, what should you write here? X plus y plus z. X plus. See, all the signs please take from the identity here. Okay, x, what, see, identity is directing you. That is giving you the instruction. So you see x. So, but what is x root 2a? Write that. Then go back to the identity. Plus y. So you should put a plus and write the y 2b. Go back to the identity. Plus z. Plus z is minus 3c. So minus 3c in the bracket. And close it. So there should be a flower bracket then. I'm sorry, a square bracket. Now again open bracket. You should write x squared. So what is x? Root 2a. And don't put a square like this. This is wrong. X squared. In x we have root 2 and a. So x squared means like this. Then identity. Go back to the identity. Plus. So plus. Then y squared. What is y 2b? Squared. Then go back to the identity. Plus z squared. So plus z. What is z? So we are only writing the expressions for x, y, z. Otherwise, everything we are taking help of the identity. Now plus z squared. What is z? Minus 3c squared. Go back to the identity. Minus x into y. What is x? This is x into y. This one. Then I'll come here. Minus. What is it? Y into z. So y is this one and z is this one. Then again minus. Identity says minus zx. So minus 3 into root 2. That's it. To see the use of the brackets, I've in the second expression also, I've opened and closed a square bracket, and inside we've used simple brackets. Inside we've used simple brackets. On the outside, we have enclosed the whole thing in square brackets. In a square bracket. Okay. Now, next, that's it. We're done actually. Now, the next step is just simplify. Simplify the squares, multiply, and all that. That's it. We have actually answered. So this is almost like the last step. So root 2a plus 2b minus 3c into, what is answer? Yeah, 2a squared, then 4b squared, then plus or minus? Plus or minus? Plus, you should not multiply plus into minus, minus, no. Minus 3c the whole square. Simplify that first. Minus 3c into minus 3c is plus 9c square. So plus 9c square minus 2 root 2 AB. Then plus 6 BC. Then plus 3 root 2 AC. That's it. Close the. Now it's a simple bracket. Open and close simple brackets. That's it. We have factorized. So you can see the result. It's a product of two factors. The given expression. So the given expression has two factors. You can see the first factor in the first simple bracket, the other factor in the second simple bracket. The factor is large, the expression is large, but it's a factor. So we factorize a given expression and the answer looks like a product of its factors. If you get a, see, like you cannot have a plus or a minus sign in the middle here. That means you have not factorized. Yeah, please take this down. Yeah, completed?
Yes, mom.
Yeah, very good. Next one. Done? Okay, Rahul, I'll share the image maybe on WhatsApp. You have complete later. Yeah, this is the next expression we have to factorize. 8x squared y cubed minus x to the power 5. So I call this the golden rule. Whenever we are given an expression to factorize, taking out the common factor, if any, should be the first step. Now, this expression has two terms. If the two terms have something in common, of course, other than one is always common. So when I say something in common, not one, other than one. So so this expression has two terms. If these two terms have something in common, taking out the common factor is the first step. That should be prioritized. You cannot do that later. You should prioritize that. That should be the first step. Now here you see there was nothing common throughout. This expression has four terms, right? Four terms. All the four terms have nothing in common. When you take two terms at a time, maybe they have something in common. Two or three terms at a time, maybe they have something in common. But all the four terms have nothing in common. So you cannot, so that's why we didn't take out the common factor there, because there's nothing common. Now here, these two terms have something in common. So you should prioritize that. What's a common factor?
X squared.
X squared, X squared, X squared. Very good. So what will you get? 8y cubed minus x to the power 3. Why? Because x squared into x cubed. Bases are same and it's multiplication. So you should add the powers. X to the power 5. Now we'll like maybe get confused. X squared into x cubed is x to the power 6. No, no, no. When is it x to the power 6? X squared the whole cubed is x to the power 6. Or x cubed the whole square is x to the power 6. In these two cases, yes, it is x to the power 6. We multiply the powers. But here you'll have to add the powers. So x squared into x cubed. 2 plus 3, 5. Okay, so this is the first step. Now x squared as it is. Nothing much can be done with that. Now inside the bracket, we have two terms. And they look like cubes, but you have to show that they are perfect cubes. Okay, so square bracket, open and close. You understand this now, right? So you're preparing to write something. So there are two terms and you want to show them as perfect cubes. So have this presentation, empty brackets ready like this. Okay, now we'll fill. What cubed is 8y cubed? Very good. 2y. 2y into 2y into 2y. 2 into 2, 4, 4 2s are 8. Y into y squared into y cubed. So 2y the whole cubed. 2y the whole cubed is 8y cubed. Minus here x. Okay. So now which identity to use? Yeah, correct. A cubed minus b cubed. So the identity we're going to use here is a cubed minus b cubed. And how do you factorize that? Or how do you complete the identity? It's a plus a minus b into a squared plus ab plus b squared. A cubed minus b cubed is a minus b into a squared plus ab plus b squared. So what's your a here? 2y. What's b? X. So now continue. Continue the equal to sign like this. Is equal to x squared. Then use the identity. You must write a minus b. So open a bracket. Open a simple bracket. You must write a. What is a? 2y. Then sign, go to the identity. Minus, minus. Then what is b? X. Close the bracket. Open square bracket. Then a square. So see, so I told you a square is not like this. It's not like this. It's not like this is a and squared. No, a has two. A is 2 into y. Both of that should be squared. So you should use a bracket like this. 2y the whole squared. This is a squared. Then sign is from the identity. Plus, plus. ab. 2y into x. Go back to the identity. Plus b squared. b is x. So for x squared, you can use a bracket or you can just put the 2 as it is. Both are, like fine. Or come back and simplify. X squared, 2y minus x. Now simple bracket. You don't have to use a square bracket now. So simple bracket, 4y squared plus 2xy or yx, whatever, plus x. And see the result? X squared into 2y minus x into 4y squared plus 2xy plus x squared. So you can see it's a product of the factors. Yeah, please write down. Just 1 second. Just 1 second. None, children? Yeah. Completed online, children?
Yes, ma'am.
Okay. Next one, same heading, factorize 1 minus 64a cubed minus 12a plus 48a squared. So how many terms? 2 terms. Can you identify any perfect? No, I said 2, is it by mistake? Oh, sorry. How many terms? 4 terms. 4 terms. How many perfect squares or perfect cubes? 2 perfect cubes. Name them. 1 and 64. Yeah, for now we'll just ignore the sign. 1 and 64a cubed. Correct. 1 and 64a cubed are 2 perfect cubes in this expression. One is 1 into 1 into 1 and 64a cubed is 4a into 4a into 4a. So this expression has 4 terms, of which 2 are perfect cubes. So now you will have to think of an identity whose LHS or RHS. Okay, so whose LHS or RHS has 4 terms, of which 2 are perfect cubes. X plus? We can use x plus y the whole cube, but we have a more specific one, no? X minus y the whole cube. Okay, so I'll write the identity wherein the part of the identity that looks like the question, I'll write that first. The part of the identity that looks like the expression here, I'll write that first. Okay, so the identity is, okay, let me write it like this. A minus b the whole cubed is equal to a cubed minus b cubed minus 3a squared b plus 3ab squared. See, we learned the identity a minus b this way. We have learned it like this, right? A minus b the whole cube is equal to a cube minus b cube minus 3a squared b plus 3ab squared. This is how we have learned it. But when you have to use an identity to factorize, you write it in, you write the LHS, that is, you write the identity in such a way that the LHS of the identity is equal to the given expression. You can change the sides and write. So you write it in such a way that the left-hand side of the identity matches with the question given to you or the expression given to you, the expression which has to be factorized. So a cube minus b cube minus 3a squared b plus 3ab squared is equal to a minus b the whole cube. So you can see here, this expression has 4 terms, of which 2 are perfect cubes, a cubed and b cubed. These 2 terms are not perfect cubes. Okay, so now what's the next step? You've identified the identity which has to be used to factorize this expression. So next is to present the given question or the given expression in this form. You must present it in this form, in this form, in this form. Let's do that. So a cubed minus b cubed minus 3 into a square into b plus 3a into b square. Because we don't know the expressions for a and b. The other things are fixed. Like we have to write a here, but cubed is fixed. So what you don't know, what you have to figure out, leave it empty. What you know from the identity, you can write that. So see, a I don't know, cubed minus b don't know, cubed minus 3a squared b plus 3a we don't know, b squared. Okay, so first write this presentation using empty brackets. Now fill. Now fill in the blanks, blank spaces. So a cubed, 1 cubed. Then 4a. Now the sign is perfect, no? Because see, 1 cubed is 1, and then already it's minus from the identity, it's minus b cubed. So minus 64a cubed. It's correct. Then minus 3, what should you fill here? A. What's your A? 1. A squared B. This is your B. Plus 3A. B. Squared is there. Don't put a square again here. We have to just fill for A and B. After identifying A and B, just fill them. Blank is left for filling A and B. Now we identified A is 1 and B is 4A. So fill them up in the spaces there. Right? Okay. So now next step is to check. We have written it like this, but it does do the terms we have got here match with the terms in the expression? That we have to check. So 1 cube, 1 is here. Then here 64a cube, yeah, it's here. Then check this one, 3 into 1, 1 squared is 1. 3 into 1, 3 into 4a, 12a, minus 12a, yeah, here it is. And then this one, 4a, the whole square. 4a into 4a, 16a square. Into 3, 48a square, yes. Order can be different. Like supposing you had this term here and this term here, that is okay. Supposing you had 48a square here and minus 12a here, that's okay. You can just exchange it and write it. But here the order is also correct. Okay. Is this fine? So first step is to pick out the correct identity that has to be used. So identifying the correct identity is the first step. We identified that because the given question has 4 terms and 2 of it are perfect cubes. So keeping this criteria, we identified the correct identity. That's the first step. After that, you'll have to use empty brackets like this. In the identity, how many unknowns are there? A and B. So we have to identify what is for A, what is for B. So use empty brackets and identify A and B. After doing that, you should simplify. Don't simplify and write the answer. Don't write 1 cubed is 1 minus 4a the whole cube is 64a cube. That you will write the question back. Don't simplify and write anything here. If you do that, you are writing back the question. Don't write. That's only the question. That's what we have to factorize. Do this in your mind or in the rough column. Simplify this, and check if these terms are a part of the question. Yeah. So for calculation, you can use a rough column, but don't write it here. Okay. So now we have checked. Now we are ready to write the answer. So the left hand side of the identity is a question. So the right hand side is the answer. See, the question is like this. See the question, 4 terms are there, 4 terms are here. 2 are perfect cubes, 2 perfect cubes. We checked everything. Okay, so we checked everything. So the question is like this. So this is the answer. This is the answer. So what's the answer? A, minus, B, whole cube. And this is nothing but 1 minus 4a into 1 minus 4a into 1 minus. So see, the answer is a product of its factors. Like what is 27? It's 3 into 3 into 3. So it can have equal factors also. So like that. All right, write down.
Yes, ma'am, completed.
Yeah. And children? Finished? Finished. Next one. Right? So how many terms? 4 terms. How many perfect squares or perfect cubes? 2. 2 perfect cubes. 2 perfect cubes. So can you identify the identity? A plus B the whole cubed. A plus B the whole cube. See, it's, like you have about 11 identities. Only one of that will match, the expression given here. It's not that I'm confused if I should use that or this. No confusion. No other identity, see, there are only 2 identities. This one, the earlier one, which is A minus B the whole cubed. A minus B the whole cubed. Okay, when you expand this, you can see the other side has 4 terms, of which 2 are perfect cubes. A minus B the whole cubed and A plus B the whole cubed are the only 2 identities which have 4 terms with 2 perfect cubes. There is another identity with 4 terms and 3 perfect cubes. That is the first one. This is the identity with 4 terms. 1, 2, 3, 4 terms. Don't see the factors. See this side of the identity. 1, 2, 3, 4 terms. And 3 perfect cubes. This one has 4 terms and 3 perfect cubes. This one has A cubed minus B cubed. Has only 2 terms. Both are perfect cubes. Every identity is unique. No confusion. 4 terms, 3 perfect cubes. Here you can see here 2 terms and both are perfect cubes. Here 4 terms, 2 perfect cubes. Here also 4 terms because here A plus B the whole cubed is equal to A cubed plus B cubed plus 3A squared B plus 3AB squared. So here also we have only these 2 identities clash. 4 terms, 4 terms. 2 perfect cube, 2 perfect cube. But again, there is a difference. Here the signs, you can see 2 positive terms. You can see 2 positive terms and 2 negative terms here. But here all the terms are positive. All the terms are positive. If all the terms are positive, you should use this one where all the terms are positive. If you have 2 negative terms and 2 positive terms, then it is this one. Okay. So now we'll have to present the given expression in this form. So A cubed plus, Rahul, you're working at Rahul? Okay. A cubed plus B cubed plus 3A squared B plus 3A B squared. All right. Okay. So what is A? 3x. Yeah, I forgot to mention this. So in the question, if you have x, y, z, then use A, B, C in the identity you write, because otherwise there'll be a clash between x, y, z in the question and x, y, z in the identity. In the question, if you see x, y, z, then to write the identity, use A, B, C. In the question, if you have A, B, and C, then identity you write using P, Q, R or X, Y, Z. If there's X, Y, Z in the question, don't write the identity also using X, Y, Z, I'm saying. Yeah, I think I didn't notice that here. This one, but it didn't clash because A is 1 and B is 4A. So here I recommend you use uh, x cube minus y cube minus 3x square y plus 3xy square is equal to x minus y the whole cube. Now here that clash didn't happen because B is 4A. Otherwise what will happen? A is 3A and then B is 4B. You understand what's happening? Yeah, it's not wrong. It's not that you lose marks or it's wrong. It's right. But we'll use like, see, this looks better. Instead of saying A is 3A, this is better. X is 3A, looks better. Y, instead of saying B is 4B, Y is 4B is better. That's all. But here that didn't matter because A is 1 and B is 4A. So it didn't matter. But still, I would suggest use XY here. Okay. Okay. We are ready now. And B is 5 by X. 5 by X. So now let's flip. A cube, 3x the whole cube. Then 5 by X the whole cube. 3A squared B. 3A B squared. Now we'll have to simplify and check. So this one is 27x cubed. This one is 125 by x cubed. And this one, let's work this. So it is 3 into 9x squared into 5 by x, correct? 3 into 9x squared into 5 by x. So what happens? X and x cancels. So 5 nines are, or 5 threes are 15, 15 nines are 135. 135x. Yeah, 135x. And then this one, 3 into 3x into 25 by x squared, right? All right. So, yeah. So 3 threes are 9. 9 into 25 is 225 by x. Yeah, we have all the terms. You have to check this. Okay. Okay. So now, what's the answer? What's the answer? A plus B the whole cube. We have done all the verification and we are successful there. So the answer is A plus B the whole cube. A, the whole cube. Now, what is 2 plus half, children? Can you cancel 2 and 2? Similarly, here you cannot cancel x and x. When there's a plus or minus sign in the middle, you cannot cancel x and x like that. So 3x plus 5 by x the whole cube. What is that? 3x plus 5 by x. Write it 3 times. Yeah, please write down. Done, children?
Yes, ma'am.
Okay. How many terms? Two terms. Perfect squares, perfect cubes, two perfect cubes. So this is an expression with two terms of which both the terms are perfect cubes. Okay, then how do we factorize? A cube plus B cube. So this is of the form A cubed plus B cubed. Now there's X in the question. So even if that's not a mistake, but if I write X by mistake, just remind me, okay? So there's X in the question, no? So we'll use A and B. If there's A in the question, we'll use X and Y, I'm saying. So there's X in the question, so we'll use A and B. So A cubed plus B cubed. The given question is of the form A cubed plus B cubed. Let's write that in the left-hand side. Now, what's the identity? Complete the identity. A cubed plus B cubed is equal to A plus B. Correct. When we write the identity, we'll write it consciously in the sense we'll make sure that we are writing the identity in that order, wherein the LHS looks like the question given. Yeah. So what is it? You don't have to use such a big bracket. 1 minute. Yeah, what should I write here? 6x. 1 by 5. So what's A? 6x. And what's B? 1 by 5. Okay. Yeah. So what is A cube plus B cube? Now use the RHS of the identity to write the answer. A plus B, 6x plus 1 by 5 into A squared, 6x the whole squared, minus AB, minus 6x into 1 by 5, plus B squared, plus 1 by 5 the whole squared. So factorize and expand can be the easiest questions you can get, because the identity will, guide you like a map. You use a map to navigate through places. So like that, this identity will help you through the answer. You have the question on one side, the answer on the other side. Should match the question with the identity and use the other side for the answer. That's all. Yeah, now after writing this, we'll have to simplify the brackets if possible. So 6x plus 1 by 5. Now you don't have to take LCM and all that. Whenever you use an identity to answer the question, just do the very obvious simplifications, like 6x the whole square should be written as 36x square. Then minus, this should be written as 6x by 5 plus 1 by 25. That's it. After this, don't continue by taking the LCM and all that. You should not do all that. You need not do all that. Okay, write down.
Yes, ma'am. Completed.
Very good. Your children? Yeah. The heading is factorize. Okay. Take down the question. Yeah, children. Okay, so we have started, right? Doing, yeah, do it. I'll also do by myself without your help. Okay, so I have to tell you something here. Please listen. So first, write the identity, the relevant identity. Okay. Now use empty brackets. X squared plus y squared plus z squared plus 2 into x into y plus 2 into y into z plus 2 into x into z. So all signs from the identity, see, all the signs from this part of the identity, not from the question, always. Now this part of the identity, the LHS of the identity is like the question given. So write using empty brackets by taking the signs from the identity and not the question. Using the identity x squared, empty bracket squared, plus from the identity y squared plus z squared, all the signs from the identity. Now fill in the spaces. What should it be here? 3a, then 4b, 5c. Okay, so now when you square, you get the first three terms. Then 2 into Okay, so do we understand that all these three terms will be positive even after filling the values for x, y, and z? Yeah, but then you see in the question given, these two terms are negative. Now, which is that letter which is common? A, B, B, C. Which is the letter that's common? B. So for that B term, fix a minus sign. Because in the identity, you see all these six terms on the LHS, they're positive. But in the question given, we see two terms are negative. So what you have to do is identify that literal factor, that letter which is common to both these terms. A, B, B, C. B is common. So come back here to that B term, fix a minus sign inside the bracket. Don't change the sign outside here. That we don't have the right to do that. Because that way you're changing the sign of the identity. This is plus. Here put a minus sign. It's minus 4b the whole square. Okay. Yeah. So now 2 into x into y. This is the x into minus 4b. Then minus 4b into 5c. Then 5c into 3a. Multiply and check. 6, 24 minus 24 AB, yes. 8, 40 minus 40 VC, yes. 10, 30, 30 AC, yes. All terms match. So now, what is your X then? 3. What's your Y? Minus 4B. What's your Z? 5C. That's it. So what's the answer? The other side of the identity is the answer. So far, we've been working the question. We've been convincing the teacher. See, like I have decoded the question and it looks like the LHS of the identity. So that's what we've been doing so far. Now the answer. What's the answer? The RHS. X plus Y plus Z the whole square. X plus Y plus Z the whole square. So this is 3a minus 4b because plus into minus is minus. Plus 5c the whole square, which is nothing but 3a minus 4b plus 5c into 3a minus 4b plus 5c. I did 2 times because the power is 2. Right on?
Yes, ma'am. Completed, ma'am.
Done also, right? Yeah. So how many terms in this expression? 3 terms. And all the 3 terms are perfect cubes. So here we have to use a conditional identity. And what does that say? A cubed plus B cubed plus C cubed is equal to 3ABC if A plus B plus C is 0. This is A cubed plus B cubed plus C cubed. Okay, A cubed plus B cubed plus C cubed is equal to 3 into A into B into C. If A plus B plus C is 0. If A plus B plus C is 0. Okay. So write the identity first. A cubed plus B cubed plus C cubed is equal to 3ABC when A plus B plus C is equal to 0. So now let's check that, okay? So what is A from this? What is A? P minus Q. Correct? When you compare. Correct. When you compare. We have 3 perfect cubes in the question. Which are of the form A cubed plus B cubed plus C cubed. So A is P minus Q, B is Q minus R, and C is R minus P. Now we'll find A plus B. We'll have to check that. Only if A plus B plus C is 0, then we can write A cube plus B cube plus C cube is equal to 3ABC. Okay, so now let's check A plus B plus C. A plus B plus C is equal to, what is A? P minus Q plus B, Q minus R plus C, R minus P. So plus P minus P plus R minus R plus Q minus Q. A plus B plus C is 0. Yes, it is 0. Therefore, A cube plus B cube plus C cube is 3ABC. Therefore, A cube is P minus Q the whole cube plus B cube, which is Q minus R the whole cube, plus C cube, R minus P the whole cube is equal to, what's the answer? 3ABC. 3 into A, this is A, into B, this is B, and into C, this is C. Correct? So first is to write the identity. The identity has a condition attached to it. Okay, so we need to first verify the condition. So A is P minus Q from the question, B is Q minus R from the question, and C is R minus P from the question. So we need to check if A plus B plus C is 0. So that's what we have done here. Yeah, it is 0. So since A plus B plus C is 0, this question, which looks like A cubed plus B cubed plus C cubed, the answer is 3ABC. This is the question. This is the question. This is the answer. So for this question, the answer is 3 into A into B into C. All right. I don't. Done, children? Oh. Completed online, children?
Yes, ma'am.
Yes,
All.
ma'am.
Yeah, very good. There is actually somewhat of 8 standard. Let's see how you can do it by yourself. Try this. Factorize 18 a square x square minus 32. Perfect. Very good.
Ma'am,
Yeah.
ma'am, I found the answer, ma'am. Actually, I think it is two brackets 3ax plus 4 bracket 3ax minus 4. Is
Very
it
good,
right?
Netra. Correct. Perfect. Correct.
Thank you.
Yeah, very good. Yarni and Sai Smriti. Good. Right. Correct. Very good, Rahul. Correct. Okay, so we have to first apply that, I know what I call the golden rule. Whenever there's something common, you should take out the common factor. So what's common between these two terms? 2 is common. Take out the common factor 2. So you have 9a squared x squared minus 216 times 32. Right? Now 2 perfect square minus perfect square. So what in the bracket? 3ax and 4. So this is the form a squared minus b squared. In the bracket, we have the expression that looks like a squared. Okay, I can use x squared here. There's also x, then you can use p and q. So p squared minus q squared. I told you there's no harm in using a squared minus b squared. So what we have in the bracket looks like p squared minus q squared, which can be, or you can use m and n, okay, which is factorized as p plus q into p minus q, where p is 3ax and q is 4. So continue from here, continue, okay? That's equal to 2 as it is. So in the bracket, we have a squared minus b squared. So how do you factorize that? A plus b into a minus b. Sorry. In the bracket, we have something that looks like p squared minus q squared. So how do you factorize that? P plus q into p minus q. So p, this is p plus q into p minus q. Okay, next one. This is also of 8th standard. Try this yourself. Factorize. Done. Online students, share your answer for the 9th one. No? Okay, we'll do together. Okay, so this is a quadratic polynomial or a quadratic expression. Okay, so to factorize this, we'll have to split the middle term. See, you have the x square term, you have the x term, you have the constant. X square term, x term, and the constant. So this expression can be factorized by splitting the middle term. It's a quadratic expression. Okay. So what's the sum? The coefficient of x is a sum, minus 22. What's the product? The product is the product of the coefficient of x square and the constant. The product is the product of the coefficient of x square and the constant. 9 into 8 along with their signs, plus 9 into plus 8 plus 72. See, we are actually making use of all the coefficients. We are making use of 9, minus 22 and plus 8. 1 second, children. Yeah, I was telling you that we make use of, every coefficient to answer this, like while working the answer. See, we've made use of 9, minus 22, and plus 8. The coefficient of x, no, please stop writing and listen to me. So to work the answer, we make use of all the coefficients. What are the coefficients here? The coefficient of x squared is 9. The coefficient of x squared is 9. The coefficient of x is minus 22. And the constant is plus 8. We are making use of all these numbers. The coefficient of x is called the sum, minus 22. And the remaining two numbers, 9 and plus 8, their product, 9 into 8, 72 is the product. The product is the product of the coefficient of x squared and the constant. How do you find the product? It's the product of the coefficient of x squared and the constant. And that's the product, 72. Now you need to split the middle term. Find two numbers which will satisfy the sum and product. So for that, you need to write the factors of 72. So you can use this method 72, 2, how many times? 36 times, 2, 18 times, 2, 9s are, no, not 2, sorry, 3 3s are, and 3 1s are. So 72 is equal to 2 into 2 into 2 into 3 into 3. So you have to use, you should use all these numbers and make two numbers. You must make use of all these numbers and make only two numbers which satisfy the sum and the product. Product will be satisfied because these are the factors of the product. The product you don't have to check. Sum you should. So you should use all these numbers and make two numbers so that you get the sum, minus 22. And of course, you should get the same product plus 72. Yeah. So the numbers are 18 and 4. How 18? 2 3s are 6, 6 3s are 18. You can use the numbers in any order. Any order you can use the numbers, but you should make use of all the numbers here, all the factors here. So 2 3s are 6, 6 3s are 18. 18 is one number, and 2 2s are 4 is the other number, and both negative. Minus 18, minus 4. Because minus 18 minus 4 gives minus 22 sum, and minus 18 into minus 4, minus into minus plus 18 4s are 72 product. And these two numbers, meaning the two numbers that satisfy the sum and product, it's unique. The pair is unique. No one can say that I have a different pair that satisfies the same sum and product. No. You can find another pair of numbers. They may satisfy the sum or the product. But we are looking for a pair of numbers that satisfy the sum and the product at the same time. And for that, the pair is unique. Meaning there's only one answer for that. Minus 18, minus 4. No other answer. No other pair can satisfy the sum and the product. It's minus 18 and minus 4 only. So that you should do the trial and error method. You should do different combinations. Like what else can you do? You have 2 into 2 into 2 into 3 into 3. Okay. So maybe you can do 2 to the 4, 4 to the 8 is one number, and 3 3s are 9 is the other number. Okay. So 8 and 9. 8 and 9. Now 8 9 is 72. But 8 and 9, what will they give you? 8 and 9, when you add, you will get 17. When you subtract, you will get 1. You should get 22. But when you use 8 and 9, when you add, you get 17. When you subtract, you get 1. 1 meaning because the difference of 9 and 8 is 1. So you can't get 22. So this pair is not possible. So then 2 to the 4, 4 to the 8, 8 3s are 24. So 24 and 3, 24 and 3. You understand? 2 to the 4, 4 to the 8, 8 3 is 24. 24 and 3. 24 into 3 is 72. Product we'll get. But what about the sum? So 24 and 3, when you add, you get 27. When you subtract, you get 21, 22. No. So like this, you should work different combinations. And you should identify the two numbers. Okay. Okay. So the two numbers are minus 18. Minus 18 and minus 4. Now split the middle term. So which means write the first term as it is. Write the last term as it is. Split the middle term. Minus 8, what is the middle term? Minus 22x. So you split it as minus 18x minus 4x. So we're not changing the question. We're just splitting the middle term. What is minus 18x minus 4x? Minus 22x. Okay. Now, to go ahead, we'll have to group. Group the first two terms, group the last two terms. So what's common between the first two terms? 9x. So in the bracket, x minus 2. This minus sign as it is. What's common? 4. And 4, minus 4x, minus into minus plus, 4 2s are 8. Now, this x minus 2 is common. And 9x minus 4 in the bracket. 9x minus 4 in the bracket. Write this x minus 2 once. Whatever is common, in the bracket, x minus 2, write that once. And then write these two terms in the other bracket. 9x minus 4 in the other bracket. So these are the two factors of the given expression. X minus 2 into 9x minus 4. X plus? Okay. What was the question I gave you? Finished online, children?
Yes, ma'am.
Okay. Read the expression. Plus? It's quadratic. We'll have to factorize by splitting the middle term. Sum is the coefficient of x, 5 root 5 plus 5 root 5. And the product, here it's 1. X square, the coefficient of x square is 1. So 1 into 30, so it's 30. 1 into 30, which is 30. So you can write 30 straight. Now factorize the product. Take the product and factorize the product. 2 15 times, 3 5s are 5 1s are. So the product 30 can be expressed as 2 into 3 into 5. Now look at the sum. In the sum, we have 5 root 5. So that means you must further write this 5 as root 5 into root 5. Only then you can get the two numbers. Because see the sum 5 root 5. See if the sum was 5 root 3, then you must write 3 as root 3 into root 3. If the sum was 5 root 2, then you must write 2 as root 2 into root 2. So since the sum is 5 root 5 it is. So we write this 5 as root 5 into root 5. 2 into 3 into 5, which is 2 into 3 into root 5 into root 5. Now use all these factors to find the two numbers. So you should make use of all these factors you see here. So the two numbers are 2 root 5 and 3 root 5. 2 into root 5, 2 into root 5, 2 root 5, and 3 into root 5, 3 root 5. So what is 2 into root 5? 2 root 5. 3 into root 5, 3 root 5. What's the sum? 3 root 5 plus 2 root 5, 5 root 5. That's the sum. And the product here, you multiply, you will get 30 because they are the factors of 30. So now split the middle term. Yeah, you can start working. X squared plus 2 root 5x plus 3 root 5x plus 30. So listen to this one. Between the third and the fourth term, what is common? What is 30? Look at 30 here. See, the third term is 3 root 5. See, some schools, like sometimes what we do, we write that express 2 root 5 already in the bracket, and then we'll just write 3 root 5 because 3 root 5 x is 3 root 5 x, right? We'll write this one as it is here. And then 3 root 5 into x is 3 root 5 x, like this, without. So this is less strain. But we need to understand, yeah, you can do that. It's not wrong. But it's actually like this. So what's common between 3 root 5 and 30, right? Yeah. No. So what are the factors of 30? Come down here and see the factor of 30. 2, 3, root 5, root 5. So 3 root 5 has 3 and root 5 in it. And what does 30 have? See here, we have written it has 2, it has 3, it has root 5, and it has root 5. So what's common? 3 is common and root 5 is common. So between 3 root 5 and 30, 3 root 5 is common, not 3, not just 3. 3 root 5 is common. To identify the common factor correctly, you need to write out the factors. What is 3 root 5? 3 into root 5. What is 30? We've already written that here. 2 into 3 into root 5 into root 5. Now what's common? 3 and root 5 is common, right? So 3 root 5 is common. So 3 root 5 is common. Okay, so now 3 root 5 into x is 3 root 5x. Plus into plus plus. Now 3 root 5, 3 root 5 into what? Is 30. So what is 30 actually? 30 is 2 into 3 into root 5 into root 5. Now if 3 root 5 is common, then you should write 2 root 5 inside. Because this 3 and root 5 is common outside. So 3 root 5 into 2 root 5 is 30. So 2 root 5. So now whatever is common here, write it once. And then this one and this one, put it in the other bracket. Yeah. Yeah, please write down. Finished? Done? No? And no? Okay. Yeah, completed. No, should I make myself more clear or you got it? You have a doubt somewhere? Okay. Oh, sorry. Try this one. You continue with the serial number 11. Okay, you can continue. If you finish, please share your answer. And children, if you finish, please share your answer. You worked or you just telling the last line? You have the steps? No. Sometimes, children just guess the the two numbers with which we split the middle term and write that with x minus and x. Yeah, that's why I asked you. You have the steps? Ah. You're right, you're right. You're right. Your answer is right. Yes. All right. So it's like this, children. If you have completed, check your answer. If you are not able to do it, please listen to me. I'm explaining now. So 210 can be expressed. So again, this is a quadratic polynomial. So we'll have to factorize by splitting the middle term. Sum is 13 root 7. The product is minus 210. Find the factors of the product. Express 210 as a product of its factors. This method, okay, like this. Now you have to write 7 as root 7 into root 7. And find the two numbers. So that is trial and error. So you see that 2 root 7 and 15 root 7. Both the numbers should have root 7 in it. Only then you will get the sum as 13 root 7. The two numbers which you write must have root 7 in them. Both the numbers must have root 7 in them. So the two numbers are 2 root 7 and 3 5 the 15. 15 root 7. So you can see I've rearranged and written here. See, this is actually a rough work. This is actually rough work. So 2 root 7 and you can see here I've written them together. 2 into root 7, 3 into 5 into root 7. So 2 root 7 and 15 root 7 are the two numbers. And then fix the signs. After identifying the numbers, fix the signs. So you should get a positive 13 root 7. But the product is negative. The product is negative, the sum is positive. The sum is positive, so the greater number should be positive. The sum is positive, so the greater of the two numbers should be positive. Correct? But the product is negative, so the other number has to be negative. Only then minus into plus minus. The sum is positive, so at least the greater number should be, both can be positive. If the sum is positive, both the numbers also can be positive. But minimum requirement, the greatest number should be positive because we put the sign of the greater number, no, when we subtract. Okay, so since the sum is positive, the greatest of the two numbers should be positive. And because the product is negative, then this has to be minus because only then minus into plus minus. And yeah, we get the sum 13 root 7 and the product you multiply, you will get minus 210. So split the middle term, common factor, and yes. So now I'll talk about the common factors between 15 root 7 and 210. Okay. 210 we have here. For 210 we have here. What is 15 root 7? 15 root 7 is 3 into 5 into root 7. 3 into 5 into root 7. So what's common? 3 is here. Here also 5, 5, root 7, root 7. So what's common? 15 root 7 is common. What's common between 15 root 7 and 210? 15 root 7 is common. So 15 root 7 is common. 15 root 7 into x is 15 root 7x. Plus into minus is minus. And the product is 210, right? What's common? 15 root 7. So cancel. 15 root 7 is common. So in the bracket, you should get 2 root 7. This 15 root 7, you have taken out common. Out of 210, 15 root 7 is common. So in the bracket, you must get the remaining 2 root 7. So this bracket, you write it once here. It can be in the first place or the second place. And then these two terms you gather and you write it in another bracket. So these are the two factors of the given expression. Completed? Completed? Rahul? No? Okay. Online children, any questions? Okay, class, use the emoji, raise your hand. Gayatri, Netra, Harsha, and Lakshana. Harsha? Okay, good. Lakshana, Gayatri, and Netra. Nice. Okay. One minute. I'll just. Yeah. This is your homework. Write down this question. Complete this at home. We'll see the answer in the next class. Taken the question? Okay. All right, children. So that's it for today's session. Thank you so much. Online children can leave the call. Good night. Thank you, everyone here. Thank you.